All right, so welcome to week 12, day one. Today we're going to talk about multi-layer memory. The cool thing about today is it's actually going to be really simple, really short, really straightforward, but I want to preface that doesn't mean that it's not important. It's really good concept to understand, especially when working with AI. So essentially, right, for day one, wait, let's get into here. Cool. So in modern AI applications, like I said, when working with AI, memory is just as important as the model, right? You can have the best model in the world, or it's been trained on whatever, but if it doesn't have context, you just kind of have this like one-off thing that's not going to actually have a conversation or deep dive into topics. So here it says, without memory, an LLM treats every request as an isolated question. You can kind of think of this like when you were working with Poly for the first time. Remember, it just kind of took your one string in isolation, checked the slots, slot comparison, all that. That's kind of all it did. You can ask it something else. It's a brand new start. That's what happens if you don't have memory. So there are different types of memories we're going to talk about today. That's essentially like short term, long term, and then vectors. And what's important for today is to understand that although there are three types of memories, that you don't have to utilize them in isolation from each other, right? We're going to talk about layering. It's utilizing all three. So here it says layering is the practice of combining different types of memory into a single architecture. This will help remember short term, recall long term, and search semantically. Just as an easy reference, you could think of short term as RAM, right? Where it's like session based. It's here, now it's not. It's sort of if you need it. Then there's long term, which you can think of as a hard drive. This information is going to persist even if you turn your laptop off or whatever device. And then there's a search engine you can kind of think of. In our case, that's going to be searching more semantics in terms of a vector database. And we're going to watch a quick video about that explains it. So here's the same exact information, just with a little bit of visual. So there's three types of memories that we're going to talk about today. Session memory, which is short-term context, stored temporarily. Long-term memory, you can think of the use case would be facts or user preferences. So like dark mode. Oh, call me Johnny, whatever it is that's going to persist. And then vector memory. This would be like semantic search and vector embeddings. So this is the same deal. Here we're just going to talk about it a little bit more just to emphasize the specifics of it. So for session memory, this lives only for the duration of the current conversation, that current session. Then there is stored, this is stored in memory, or, oh, actually, you know what? Hold on. Give me 1 second, guys. I know we're recording, but this isn't updated. Okay, so assuming that this is lightning quick, there we go. You're not going to notice the difference really. It's just a few word changes, but so for session memory, excuse me, we've established that this lives only for the duration of the current conversation, the current session. It's stored in fast temporary storage. An example would be Redis, which is an open source tool. I do have a link if you guys want to learn more about that. I don't think you're going to use it in the class, but it's something that may come up in your future. Session memory is best for continuity in chat, in multiple step tasks, right? That's the difference of saying like, I don't know, what year was America founded? And then it gives you the answer. You guys should know. All the soldiers know. I won't put you on the spot. And then you're like, then you say, oh, cool, who founded it? If it says who founded what, it's like, oh, damn, there's no continuity here, right? So then, an example, remember you said the budget is $200. What? What's up with this example? Oh yeah, it remembering what you said. So in this case, it remembers that you're talking about America, or remembering that the budget's 200 without having to restate it each time. So long-term memory, structured. This is going to persist between sessions. So this doesn't matter if you leave, go back, turn your computer off, turn it on, sign out, sign in. It's long term. This is going to persist between sessions stored in database or a document store. And this is best for explicit facts, things that aren't going to change. Best for user settings, things that shouldn't change unless explicitly changed. And profiles. And this could be profiles in the sense of like, your, like if you use ChatGPT, it kind of knows who you are. It kind of knows your job. It knows what school you're going to, whatever it is. This stuff would be stored in long term. Here's a note. While vector memory is also long term, this layer, if you guys have context, you know this layer refers to long term, right? Long term memory handles specific facts that we don't need to search for. So, and that's in the sense that long-term memory is like pulling it. It's not necessarily searching. It's just how, how a database works, essentially. Then there's vector memory. This is probably what you're least familiar with. We are going to watch a video in a moment. It's kind of like, it's just 2 minutes, but it feels a little bit longer. So we might just watch 40 seconds of it. But vector memory, it uses vector embeddings to store and retrieve data based on semantic meaning. And then this is great for knowledge bases, document searching, recalling past conversations beyond token limits. An example, say you're searching past meeting transcripts for budget approval. This would be the key word here, for budget approval. Even if that exact phrase wasn't used. So if you were having a conversation and you say, hey, whatever, on Saturday, what did we talk about with the budget approval? And nobody mentioned the word budget approval, right? But let's say instead they said, how much money we have left for the year. That's something that in a traditional database, you can't make those connections. With a vector memory, a vector database, you absolutely can make those connections based off a semantic meaning. So right now I'm going to just show you guys a little bit of this video. It's similar to that 90-second one.
What the hell is a vector database? Or what the hell is a vector even? Well, that's easy. A vector is just an array of numbers. But what's cool about vectors is that they can represent more complex objects like words, sentences, images, or audio files in a continuous high-dimensional space called an embedding. It's kind of like this. When you go to a party, all of the jocks sit around the TV and watch football. Meanwhile, all the girls find the dance floor, while you group together with all the programming introverts to talk about vectors in the corner. Notice how all the similar objects are grouped together. Embeddings work the same way, except they map the semantic meaning of words together or similar features in virtually any other data type. These embeddings can then be used for things like recommendation systems, search engines, and even text generation like ChatGPT. But once you have your embeddings, the question becomes, where do you store them and how do you query them quickly? That's where vector databases come in. In a relational database, you have rows and columns. In a document database, you have documents and collections. But in a vector database, you have arrays of numbers clustered together based on similarity, which can be queried with ultra-low latency, making it an ideal choice for AI-driven applications. Relational databases like Postgres have tools like pgvector to support this type of functionality, and Redis also has first-class vector support. But a bunch of new native vector databases are popping up, like Weaviate and Milvus are open source options written in Go. Then you have Pinecone, which is extremely popular, but is not open source. Then you have Chroma, which is based on ClickHouse under the hood,
And just heads up, you don't need to remember all of these possible, different libraries and frameworks. For now, just understand that things are going to be grouped based off of semantics by having having the score that essentially says how closely related they are. And then this next portion is just a little snippet of code that's beneficial to understand as well.
Any other options from there. Let's jump into some code to see what it looks like. Here I'm using Chroma and JavaScript, and the first thing I'll do is create the client, then define an embedding function. In this case, it will use the OpenAI API to update the embeddings whenever a new data point is added. Each data point is just a document with an ID and some text. And finally, we can query the database by passing a string of text just like an LLM. What's most interesting though is that in the query result, we get the data back in addition to an array of distances, with a smaller number indicating a higher degree of similarity. That's pretty cool, but the real reason that these databases are so hot right now is that they can extend LLMs with long-term memory. You start with a general purpose model like OpenAI's GPT-4, Meta's Llama, or Google's Lambda, then provide your own data in a vector database. When the user makes a prompt, you can then query relevant documents from your own database to update the context, which will customize the final response. And it can also retrieve historical data to give the AI long-term memory. In addition,
Okay. And then for now, you don't need to know the rest of that. Let me ask you guys, and I don't need you guys to be professors. Can someone tell me what we just watched, what you grasped.
Oh, as far as vectorization and storing data as far as vectors, use in math, to essentially you're creating a reference. With SQL, essentially you create like a row and a row and a column. And a column, those two things represents array of referencing that specific data point. But with a vector, you have three basic data points that acts as a reference to allow you to find and reference that specific data point. And it works because again by math, because you have what you have way vectors work in math is of course you have a single origin point. From that origin point, you can gauge the distance or you can map the distance in order to find an object using 3 points to 3 points or 3 reference points. So that single origin acts as like the single origin acts kind of like it's a starting point
Mhm.
for everything. Since we all have the same reference point and to start from, we can all, I mean, no matter how you change the distance or change the vectors themselves, it's always going to be consistent because you always have that origin. That makes sense.
Yeah, that's killer. Would anyone have a answer that is, so your answer is obviously accurate. Does anyone have an answer that would pertain more to vector memory, more specific in the use cases that we would use it? Or even more of a plain English?
So I'll go with they mentioned vector databases stores li uh, arrays of numbers, and as such, it's blazingly fast to query against, making it a good use case for LLM and machine learning applications.
Yes, that's also correct. Does anyone else have something they would add or how they would portray what we watched in regard to vector memory? So the one thing I would say, um, like if you took anything away, I would hope that you'd understand that when utilizing vector memory and vector databases, that or a vector database, that you're going to get back a score. The lower the score, the closer the meaning. The higher the score, the more distant the meaning. That's essentially semantic searching. That's when you say, "Hey, budget approval," and it knows that it says how much money is left or whatever. That's more of an abstract, but it understands that those two strings are related to an extent, and yeah. So that's essentially what it is. It's so everyone gave the right context, just different aspects that you guys were looking at. You are going for sure going to use vector database. What is this, week 12? Week 14. But when you use it, you're not going to have to know how it works. That's kind of like the privilege, I think, of being an engineer in this year. You just more have to know what it does and then how to hook it up. All right, so today's focus is layered memory, as we had mentioned earlier. There is single layer memory, which you could potentially use for basic chatbots, but you're going to hit limitations. Then there's multi-layer memory. This is where you're using 2 or 3 of the layers that we've discussed, right? Which is short, long-term, and vector memory. And then this ensures with multi-layer memory, it ensures that you can store and retrieve the right kind of information from the right place. And then with layering, if you do it right, it should balance, or you should balance speed, cost, and relevance. That's one of the benefits because it's like with memory, it's easy to say, hey, stick everything in a hard drive, right? Long-term memory, we'll get it. But that's not always, it's not even how your computer works, right? Your computer has RAM and a hard drive for a reason, and they store different information for different reasons. So we're just going to do a quick check your understanding. I know this is pretty basic, but just to make sure we're all on the same page. Uh, which type of memory is best for retrieving information from thousands of past conversations? And once again, it doesn't matter if you're wrong. Just tell me what you think.
Vector memory.
Vector memory. Does anyone disagree? Does anyone agree? Quick change. I saw you put your no up, and then when I switched the question, you changed it perfectly. Okay, great. So yeah, the answer is vector memory. Because if you're gonna look from thousands of past conversations, you need some sort of way to reference, gather meaning. Exactly, that's what vector memory would do for us. Which memory type is lost when the user closes the chat?
Session, right?
Yep. Yep.
Absolutely. And then what's one real world app or service you've used that's likely to use all three memory types, which would be multi-layer memory? Out of these three, which one do you think it is?
See.
Yeah.
Yep, absolutely.
D?
Say again?
Where's D?
What?
Already.
Somebody said D, as in dog.
Oh, I only heard C. Did someone say anything that was not C? All right. Yeah. No, yeah. Either someone's lying or someone misheard. But yeah, the answer is C. It would be a AI-powered customer support chatbot, at least a decent one. A calculator obviously wouldn't have any use for that. A simple text editor also wouldn't. Actually, now that I'm thinking about it, would it? Because I wonder if you can use short-term memory before you save, use long-term memory when you save, and then if you can use vector for some sort of built-in like thesaurus, maybe? No, not necessarily. No, I don't know. Maybe there would be a better use case. But anyway, I was just trying to think outside the box here. Okay, so like I said, today's pretty short, but this is just the first one. We got one more short lesson for you guys. So now you know what multi-layer memory is, so we're going to just talk about like the why. And I kind of feel like every time I talk to you guys, I'm always like, why? It's super important. Kind of like with the example we got today from Nick with the interview, he had to defend his, his stance already, which is the why. It's a very important part of the job. As an engineer, it's not to just, oh, I happen to come up with the right answer. Because remember, there's always different answers. It's about knowing why. So today, what's to say? LLM-based applications are only as good as their ability to recall and use relevant information. If you rely only on one kind of memory, you're either going to lose important context, waste resources, or create a brittle system. So the core idea, just as humans use short-term memory for the present and long-term memory for history, we use associative triggers to retrieve buried memories, similar to how AI uses vector search. I will say that this is not a one-for-one comparison, but whoever wrote the first draft of this had like another analogy. As someone that's like super into like neuropsychology, I was like, nah, that analogy is not right. So I just made it a little bit closer to reality, but it's not super relevant. It's just an example. So then, why it matters. Without multi-layer memory, this is without. Wait a second. This is the older version for some reason, even though the other page updated. But anyway, so without multi-layer memory, your context drops after a page refresh or a server restart. The relevance decreases when retrieving large unfiltered data sets. Your cost will increase when embedding every piece of history from every request, especially with like tokens, if you're, tokenization with the LLMs. And then performance slows when searching big data sets without smart indexing. So then with multi-layer memory, what we're talking about today, session memory delivers instant conversational flow. Long-term storage retains user-specific facts for personalization. And vector search finds semantically relevant information without exact keywords. So then together, you're going to optimize your cost and speed based on how you're querying. So example scenario. If you have a customer support bot with multi-layer memory, and then a customer asks about a recent order, the bot remembers it until the browser refreshes, until it closes. And then if you ask it, hey, what purchase did I make 6 months ago, it wouldn't know. So then now it's not even a customer support bot. At that point, it's just a random bot. But if you were to add multi-layer memory, the session would know the current details that we've already talked about so far, within that session in the chat. It's going to know your purchase history, or not know it, but it'll be able to retrieve it and utilize it as if it knows it. And then it can use vector searching to find relevant products, troubleshooting steps from thousands of documents, even without exact matches. So then how does this actually work in practice? Like, what's the flow? So the flow here is that the LLM, in our case, is going to get a user prompt, right? Just the input. It's going to first check session memory for recent relevant context. And that's because if you already discussed something, like even if you discuss something that normally you have to pull from long-term memory, you wouldn't have to pull it again, right? It's just right there. It's the fastest one. Oh, we mentioned this earlier. I already know it. After session memory, if it's not found there, then it's going to actually utilize the long-term memory. Then if it still can't find it, then we can utilize vector search for semantic matches in large data sets. And then, yeah, just here it just says it makes it richer, more accurate, which you guys already know. So here would be my question. So far, does this flow make sense? And in fact, actually, let's talk about this first. So here's just a visual representation of what we said. The user prompt arrives. The system's going to check the memory. If it finds whatever it's looking for, yes. Okay, cool. Let's combine the results. And then let's generate a better human response, human readable response. But if it's not found in the session, then it's going to check the long term. Same thing. Did it find whatever we're talking about in long term? If yes, once again, it's going to compile the results, and then it's going to generate the human readable response. And then if it doesn't find it here, it's going to check in vector. And then here you could say, oh, what happens if it doesn't find it? Well, it doesn't matter. We've hit the end of the line. So regardless, whatever it has, it's going to just compile what it has, even if it's an empty array, depending how you set your thing up. And then this human readable response, if you would, is going to say, oh, damn, we don't have shit, right? We don't have an answer. But it's going to present it in a way, where to the human, they can understand that. So my question is, does this flow make sense? Or does the flow not make sense to anyone? Okay, cool. Here's going to be my think outside the box question for you. So we all agree that this makes sense. Start with session, long-term, vector. Would there be a use case where it makes sense to not do this flow? But let's assume let's say we have the capability. So let's say we have multi-layer memory. We have all three of these layers. What would be a good use case to not use this flow of session, long-term, and vector?
Mm.
If you're just starting a chat, there's no session memory to access. So skip it and go to something else.
How would it know that there's no memory to access unless it accesses it?
Oh, so if it empty versus not available at all is what you're saying.
Yes. Well, you're saying empty versus not available? Well, I just mean either way, how would it know?
It would look at it, say,
Yeah,
oh, there's nothing in the session memory. We need to go to two other types to answer this question or prompt or whatever.
sure. But then the flow that you're telling me is still the same flow. It's just a different use case of that same flow. The question more specifically is, when would you not want to check, let's say, session memory before long term? Or not check long term before you vector? Just as an example, it could be any one of these, but just essentially changing the order. When would changing the order be relevant? And Cam, I did see your hand raised. Did you still want to contribute?
I was thinking about examples like what Nick was saying, but you kind of posed like, okay, different workflow, so I don't have an answer for that.
Okay. Does anyone have? And remember, it's okay if you're not right. This is just about thinking, not about being right. When was it?
Maybe in some security related, like, I don't know, in a government, like in a skiff or something, maybe you don't have access to a large data set with vector search. So you don't do that step at all. Or maybe there's a reason why you wouldn't want to store session memory. I can't think of one, but I'm sure there is. And in that case, obviously, you wouldn't want to check session memory.
Well,
Okay,
I think you kind of
interesting.
said it too. Like if you have a key, I don't think you want to store that key in the session memory, would you? Or any kind of secrets. But then again, I can't really. I don't know. I mean, the use case could be I don't know if you're checking a user's if like finance, if you're making a purchase, there's no real point to actually search for session data when you actually need to find the customer's PII, wouldn't you?
That's interesting. So, in your case, what you're referring to something like a chat bot for a bank, maybe. Would that be correct?
Yeah,
And I
and
say,
of
hey,
course that person is making a purchase, so you want to, or you need to access that person's financial accounts, though. And that's definitely never going to be stored in session memory. It's always going to be stored in long term. And for some other use cases, for good reason, where you wouldn't want to store somebody's like PII in short term memory. You don't want to do that, though, wouldn't you?
But would you then like any have some kind of algorithm that checks for PII and then like automatically stores that in long term that's more secure, or is that something that you would just have like an ignore on to like have no storing at all? I guess it would depend on your use case of like if you're going to allow that kind of information on your session, like in your system.
Um,
Because I know like well, like the chats that they flag whenever like a key, because I may or may not have done that when I was working with APIs. Like, so like it's like you should redo your key, but it stores it, and that would be kind of in session, I guess.
well, no, because the thing is, I know that for a fact because I know there's an issue with like with web browsers where they don't store. Isn't yeah, like with JavaScript being able to access somebody's
Mm-hmm.
like key or something like that. Because the browser doesn't allow you to access it. Like the browser doesn't allow you to access session memory. Like it'll be able to store those temporary keys, but you can't access it, right? That's kind of what I was thinking. I don't know if I'm articulating it correctly.
Yeah, just to clarify, and then we'll let Cam jump in. Whenever you're utilizing like a key specifically, that would be like a secret, right? There's like public keys and secret keys. If you're referring to secret keys, you're correct. You're not actually going to store that anywhere that it's accessible by a user directly. Um, Essentially, what you would do is kind of store confirmation of that key if it's already been utilized by whatever service it needs. And then even when your software is accessing that key, it's not necessarily saying, "Oh, hey, I'm the front end. I'm using this key." It's saying, "Hey, I'm the front end. I'm triggering the location of this key that I'm never seeing." And then that key is being handled by like whatever other backend. So yeah, the key would never be stored in a session memory specifically. Cam, you wanted to contribute?
Yeah, so your original question was what is there a use case where you would just go straight to vector search, right?
Could be, yeah.
And I was thinking like if it's not personal or specific, that's when you would want to go straight to like a vector search or like um how do you cook a perfect steak, right? It's not personal, it's not business related or anything like that. So I would think there's got to be some type of way to where you can kind of filter that and move it down to the respective workflows. So now if I'm asking, hey, what is my favorite steak recipe? Then it would go down to, session memory or long term. That's what I was thinking.
Yeah,
Yeah.
if I could build on that, Cam, it's almost like when you have domain specific knowledge, like recipes from a famous chef that you've vectored and you've got a RAG process of, storing it. So then the user might ask that question, and rather than, like we know it's not personal, so the user doesn't know that. So your application might go straight to the database, right? The vector search of cultivated memory. And then other domains, could fit that model as well, where, like maybe it's a medical question and you don't really want to, get like the user's um, responses, but rather medical textbooks that have been vectored.
So let me stop you guys real quick. So far, what Cam proposed and what Troy elaborated on, would anyone disagree? Okay, so I'm going to say congrats, Cam, for broaching it and Troy for expanding on it. That's absolutely correct. If you're accessing something essentially where session memory isn't relevant, now we often kind of think of chatbots, especially in the new age of it, where it's conversational. But there's not always times where we need it to be. Now, most of the UK use cases are, so this would be a normal flow. Absolutely. But like you said, if you need to access something specific where nothing else really matters, then yeah, why does the session memory matter? Unless you're going to derive some additional use case for that. But yeah, absolutely. One of the examples of this actually is week 14. So in 2 weeks, that whole week we're creating a bot that's going to use my city. I live in El Paso. We're going to use El Paso's municipal codes. And you can ask the chatbot any municipal code question, and it's going to give you an answer from that code specifically. It intentionally doesn't use session memory. And the reason why is if it has session memory, let's say I ask it a question about littering laws. Then let's say it gives me the answer. Then I ask it another question about, let's say, not littering, but illegal dumping, which is like littering on crack, right? It's on steroids. Illegal dumping. If it has session memory, is it fair to say that it may now confuse or combine the previous question or previous response about littering with the new response about illegal dumping? I mean, they're kind of close, right? That's going to mess it up because in this case, we're pulling up legal documentation to get an official answer. So session memory can skew let's say the purity of the response in this case. So exactly like you said, if we just kind of need something specific, session memory could like muddle that up. So yeah, great job, guys. Great thinking outside the
Hey,
box.
Jonathan.
Yeah.
So that's a reason why you asked that question of like, just bypassing the normal workflow that you showed us. Would latency be an issue? I don't think it would be, right?
Latency in regards to what? You're saying going through
Like
this whole flow?
instead of like trying to find a bypass like a filter, right? It just goes all the way down, right? And if it doesn't match anything, then it just keeps going down the chain.
Mhm.
It is I understand the reason of, I guess, what you said where it could taint your response from the session memory.
Mhm.
Are there any other reasons why you would want to bypass?
Besides tainting, because so what you're saying is just in terms of the response speed or even computation.
Yeah, is latency another reason why?
Yeah, I would assume so. I would assume so. Because I'm thinking one, obviously, yes, less steps is less steps, period, right?
Sure.
But based off of the speed, is it noticeable? Is it significant?
Right.
I'm,
Yeah. I
I'm
mean, if it's like a second compared to 3 seconds, it's not that bad, right?
Oh, that's funny. When you said a second to 3 seconds, I was thinking, oh, that's significant. But it's perspective. It could be based if you're
Sure.
talking specifically on like user expectation. Even think about it in the sense of, let's say you're making a website, right? Not memory related, but just making a static website for a business. The bounce rate, that's when a user leaves, is 3 seconds. In fact, I think it's way less now. This is 10-year data I'm spewing at you, 10-year-old data. When a user goes to your website, they have 3 seconds before they're gone, unless they have a reason to stay. And this is all subconscious. So in our world, seconds can feel like eternities for loads, information gathering, things like that. If we're talking about milliseconds, fractions of a second, I think that's where we make the argument that it's not necessarily significant, but it's perception. So to answer your question, would latency in this case be significant? I would assume possibly, maybe if our session is extremely long, perhaps.
Mhm.
I'm not quite sure.
Are there any other reasons?
Besides muddling up the results, uh,
Mhm.
that's a good question. I'm not, and that's where we have to think critically. I'm not 100% certain Because the only other examples that I could think of were like security. That's why at first when Nick had mentioned security, I thought he was gonna go the same route that I went, which is just kind of like, hey, we need a cut and dry response. Aside from that, I'm not certain at the moment, but there has to be.
Okay.
And that's kind of the whole point of everything, right? Everything that you're learning in this, not just this class, in this boot camp, and not just the boot camp, your whole career, you're learning a specific use case, and it's really easy to say, hey, this works. I'm going to apply it to every problem I run into. But that's not an engineering thing to do, right? It's not, if it was one size fit all, we would have one optimized procedure for everything. Everything would have the same solution. So to answer your question, I'm not certain what other use cases are. I'd have to think about it. And then I would try to challenge everyone here to think about it as well. Maybe we can discuss that at the at stand down today, see what else we can think of. All right, cool. So implementation considerations. And this is kind of like what we're asking here in terms trade-offs. More layers equals more control, but more complexity. So that could be a reason to not use all three or just the layers that make sense. Priority order. Often, this is the standard one that's most common, if you would. Session long-term vector, which we've talked about. Can vary, which we've talked about. Fallback logic. Always define what happens if no memory returns, right? If it just doesn't exist, you want it to just give a cut and dry default response, make something up, infer. Sometimes, like, if you're actually talking to like ChatGPT about nonsense, there's a lot of times it hallucinates, but I'm pretty sure a lot of times it's not necessarily hallucination either. A lot of times let's call it an intentional design or an intentional response to answer our question, which isn't necessarily the same as hallucinating, right? Hallucinating is like where it's making stuff up, opposed to saying, hey, there's no answer, so this is my best guess. And I think since it doesn't clarify, since it's always speaks empirically, we kind of take it all as hallucinating. All right, so check your understanding. What is multi-layer, or what? Why is multi-layer memory important for AI applications specifically? A, B, or C?
B is in Bravo.
B is in Bravo, because it combines speed, persistence, and semantic intelligence. Yes, that's correct. And that's exactly, Cam, what you were hitting on earlier. Like, oh, what about the latency? What about the speed? It does. I don't have the data, but I mean, it has to on some level. And then what happens without multi-layer memory? Any guesses? Alpha, Bravo, Charlie?
Bravo.
Correct. Without multi-layer memory, your context could drop because you're not utilizing all the storage. Or here specifically after page refresh, right? Because you're not persisting with session. Your relevance can decrease, especially if you're not utilizing vector semantic searching. And then your cost can increase as well. That's if you're just using, like, if you're overkilling, essentially. Let's say you're saving everything to long term and pulling everything from long term opposed to using sessions, stuff like that. All right, last question here. In the customer support bot example, so just pretend it's a customer support bot, what does vector search enable?
B.
B, finding semantically relevant information without exact keywords? Does anyone disagree? All right, audience, 100%. And good job, because it is B. So you are now experts on multi-layer memory. Today's assignment, okay, here's the cool thing about today. Like I said, today's like an easier day, but it doesn't mean that this is not important. Because today has to do with designing, thinking, and documenting. And this is all highly relevant should be for you creating your own projects. Definitely if people are paying you. In companies, you can't really do anything unless you're told to do it or you lobby to do it. And a lot of times you're going to know the right answer, let's say. You can come up with the right answer. And if you can't do it because you got to do what the other guy does or, what the other teammate said because they're better at documenting or explaining, it gets super frustrating. So this is a skill to save your frustration and make you seem more of an expert than maybe you are even, right? Who knows? So anyway, today's lab and assignment are actually identical, which normally we don't really do, right? Normally we'll expand on it or give you like a completely different thing. This lab is not about coding, it's about concepts. So I'm going to show you the concept that I created, essentially, and then you're going to do the same thing, but with your own hypothetical app. So the one thing you're going to have to do first is come up with your own app that's not mine, and it should be different. So my app is a therapy bot. So think about it like a chat, not a chat wrapper, right? But we're creating our own chat AI, which this is just concept of a therapy bot. You can talk to it, knows your information, whatever, right? So the first thing we want to do is talk, and I'll just write it out here so we can kind of just think about it together. And this we can also do as like a team, like we can talk about it so we all understand the concepts. So we know there's three types of memory, or multi-layer memory. For our assignment today, you don't have to use all three and you don't have to use the same order. But remember, this is the most common, so it may behoove you, not to give you guys flashbacks of your drill sergeants, it may behoove you to go in this order just so you get experience with that full breadth of this multi-layer. So here, if I have a chat bot and it's going to use session memory, the question is kind of like, what do I want it to know in terms of just context, right? So that's kind of the question. So, all right, cool. If it's a therapy bot, the one thing I probably want it to know is like this. And we can even talk about how it would know, but it's not as relevant for this use case. Oh. Wow, we got spelling errors all day. So like, for example, this chatbot, it's a therapist, right? I would want it to know the current mood of the user because especially like in a field like therapy, and I would say maybe for any sort of communication that we're doing with our peers, our friends, whomever, usually if you understand that person's mood, you're probably going to respond differently, right? Like if someone is happy and excited versus sad, you may use a different tone to respond, right? Someone like their family member passed or whatever it is, right? Or you may use different wording, So that's something I would say, yeah, I would want it to know. Another thing I would want it to know would be, I would say context of, let's say the user's concerns as an example. And then the hypothetical that I made up is like, I've only been sleeping 3 hours a night, let's pretend. Now, it doesn't mean that, okay, yeah, the user only put in this one very blatant string. It can also mean that it could have been inferred by saying, oh, I stay up late. Something like that. Oh, I've been extra tired in the morning. Oh, I just started playing whatever new video game after work, before bed or whatever it is, right? This context may be important to understand. That way, this therapy bot's starting to build a new, let's say like a potentially an evaluation and a tone that doesn't exist in long-term memory. Maybe this wasn't talked about before. So there's no long-term search that's going to say how the user feels at this moment. There's not going to be any potentially vector search to say how the user feels in this moment. Another thing that could be good for, so here, I had one called tone preference. And now here's the thing that I want to be clear, because you're going to do this today. All of these variables here are made up. It's not that you're going to make your own app, whatever app you choose, and say, oh, it has to have current mood or this. No, it's up to you. What is going to be your use case for session memory? In my case, like I said, I just want a therapy bot, and this would be the context that I have to create to make this a viable, not like a BS chat wrapper. You know what I mean? That's just using whatever pre-made garbage model and is pretending, it's, we're giving it more context to make it more of, let's say, the human experience. So here, tone preference. Like I said, if it knows that the mood of the person is anxious and it knows, oh, now it's going to start inferring like, oh shit, this guy's not even sleeping. Maybe in our case, it's going to ensure that its delivery is gentle, like I said, based off a different context. Here would be my question, just so we can all kind of think outside the box here. Based off of this current trend, and let's say without looking at the lab made today, just here, what's something that you think could be in session memory for this therapy bot specifically? And you don't
I
have to
think
worry.
my question would be, so is the premise that, because you're saying like these are like current moods and everything, like current information, is the premise that this is the normal user? Because I feel like if it's a recurrent use, that would be something that would be sourced to long-term memory to like store patient information or or like diagnoses or what, which, ethical issues there, whatever, for a bot. But like background conversations, previous conversations, versus current. I mean, the session information would just be like everything that's discussed in this current session. So anything discussed in the current context would be kind of stored in the session versus, and then maybe there would be an evaluation of what needs to be stored in long term versus done away with. I don't know.
Yeah, absolutely could be. But saying in this sense, just to make sure I'm understanding correctly,
That's just all the context then, I guess, maybe.
yeah, it would be how you want to architect it. There's no wrong answer. But to ensure that I'm understanding correctly, um, are you saying that the current mood of the user should not
No,
be in session, but instead should be long term? Just
I
like to,
would
for
say
to
my question is the premise that this is a recurring user that previous sessions should be cached in long-term memory. Because then in theory, the current mood would turn into a like last session for like the next time. This is probably outside of the scope of your question. I was just like, is the thought that this thought would be used multiple sessions and then that would kind of change the context of what would be in long term versus
Yeah, no,
it.
solid. I get what you're saying. So yeah, that's out
I
of the
don't.
context of what I was asking, but that's not like a wrong context. Like it's not a wrong question. It's a great question. Um,
Well, no, I don't think that works specifically to the use case you're talking about because if you're talking about the person's mood, a person's mood is going to change from session to session. So
But you
that's
would
not
want to
going to work.
know, but you would want to know, like, so if I've been using this therapy bot 5 times and every single time my current mood has been depressed, maybe that would trigger a different response than if only this is like in session memory storing the current mood and it's just my current mood. I feel like those would be two different responses that I would want the bot to have.
Well, yeah, what I was going to say, I don't think it's going to be relevant to the current session, but you raised a very good point, which I was about to say is like the decision between what to store and what not to store long term. And yeah, like it brought up another good point. If a person's mood is consistently this one thing over and over again, that may be a good thing to want to store it in a long term session so that the chatbot can use to make another determination. But I'm not, I don't, but I mean, I still stand by what I say because I don't think it's going to work from session to session. But again, you did bring a very great point. What the decision to what to store and what not to store in long term. Like, I don't know, if a user keeps saying like I keep wearing a dress because of her, then you probably want to like, and the chatbot doesn't understand the reference of her. But then if it checks a long term memory, sees that her refers to that person's mother, then something like that, you know?
Yeah, there's some type of in your current session. How is past sessions? I like where Kathleen was going. If this is an application that the user is using, multiple times in a row, how does historical chats get reflected in current session, right? That's a design decision. So, for
Yeah.
example, we've got tone preference right now as gentle based on the person picked up, the chat bot understands anxious as the current. But if they were just talking to the chatbot yesterday about some very, troublesome things or some very significant, like you would want to bring some type of historical reference to your previous session into the current session in some manner.
Maybe, maybe not. It's a good design
Sorry to take
decision.
us off on a sorry to take us off on a tangent.
No one took us off.
No, what was the
This
original
is
question? The original
fantastic.
question is what else, other things we can include?
Well,
What
wait,
should be in session?
hold on, hold on. We're not just going to dismiss everything that was brought up. This is fantastic. I'm super proud of all of you. This is great. It's one thing to learn something and then memorize it. Like that's cool. It's another thing to sit here and ask these design questions. No, this is fantastic. Um, you're all right. Each one of you is correct because there's no answer ever. Now, that's like the whole point of everything with design. There's no answer. It's what is best for the use case. And once again, there's no answer. It's perception. Now, I mean, you could do something and it's dog shit. All right, then you could say that's a wrong answer. Two people can do something and it's both appears to work, and that's where now you got the debate. It sounds like for both of your things, right? Because we have two students saying two things, saying, hey, it is relevant. Certain things are relevant to session memory, even if it's not brought up in that session. And someone else is saying no, someone's saying yes. If you both created the same bot with both of your different design theories, from a potential user perspective, it seems like both of your bots are doing the same thing. They're both working. But then what's different is the methodology. Who's to say which one's actually better? Now, from there, then we can maybe do data collection, do surveys of the participants, whatever it may be, to come up with an empirical answer. But at least within today's session, you're both right. If I had to say, though, personally, I don't think you're both right. But that's the whole point, is right, because then I'll give you my design preference that I think is correct. I would say, and once again, this is an empirical, right? We haven't tested anything. I would definitely make the argument that what's stored in long-term memory, at least specifically their usual mood, if we're tracking their current moods, documenting it, and coming up with a baseline of usual, I think we can make the argument if the current mood is not in alignment with the usual mood, there has to be a reason. Then we can also make the argument that if the current mood is positive in relation to the usual mood, it's a positive change. Maybe they got a new job. Maybe, who knows what. They win the lotto, right? On the other hand, if they're normally excited, and we have the baseline of that, and today they're anxious, maybe this can even trigger something for more probing questions. Maybe the user is not even asking or bringing up anything that would allude to anxiety, right? But we can say, dude, you're anxious. You're normally excited. What the hell's going on? But then also think about it this way too, not to get too in the weeds here. What if you're normally depressed and then now you're anxious? You could say, is one more positive or negative? No, but they're both negative. They're different. That has to be an indication of something. And I wonder if we're pulling in longer term stuff. Let's say they actually have a formal diagnosis. Let's say they have PTSD. These aren't, by the way, we're just making stuff up here. There's no actual correlation, right? So don't think this is a psychology lesson here. Let's say they have PTSD and normally they're depressed. Let's change this. Normally they're depressed and today they're anxious. It's possible now that if it's going to search in here for, let's say, what did we say, depression traits, right? Let's say it has access to depression traits. What if there already is an existing correlation from depression to anxiety. Then maybe it can even say, hey, you know, this is a normal expected change. We don't need to probe into it too much because this is a fluctuation of this. Or maybe it's not. And now we really need to probe. So to great point, Kathleen, that you brought up, and great counterpoints that were brought up. Nobody's wrong. That's the whole point of design, is to figure out how things are going to play with each other, to give the user a good user experience, and to create outputs that are viable for whatever the goal is of your application.
You're probably getting to this, Jonathan, but how might you architect that? From what we've learned already today and previous course, is this a Lex? Are we building like advanced slots here and how would you do that?
So that's a whole nother question. So for today, we're focused on memory, design of that memory. Depending on how much time we have, and I could double check too what the specifics of the assignment say. Remember, because you're not actually going to be obligated to build this. I would say if you have time, if you get excited, because now you're designing something, if you want to build it, go for it, man. But to answer your question, are you asking me within the context of your expectation today, or the context of this specific app?
This
hypothetical?
specific app. Yeah.
Yeah, put no thought into it.
Okay. All good.
Yeah, I put absolutely no
Um,
thought into it.
I said along those lines, I had the same question, and it might just be because I missed the first little bit of class.
Mhm.
But when we're talking semantic search across knowledge, are we talking like RAG, like you're providing it knowledge, or is it like just all of internet? Are we talking LLM or
Oh, in terms of semantic search in vector?
yeah? Mm-hmm.
Well, no, it can't be all of the internet because then it wouldn't be vectored, right? That would just it being
True.
access to.
Yeah, but like a
Unless,
specific like RAG or like a specific document set.
yeah, I think the easiest to perceive, especially because we have a lot of mixed backgrounds here. I think the easiest to perceive is just imagine a hard-coded vector database of information.
Okay.
And then we're going to semantically, search when needed. In this case, I brought up depression traits. Actually, let me see what I wrote on the thing. There's something, and you guys don't need to memorize this because this is just for this one use case. There's the cognitive behavioral therapy technique database.
Oh,
Essentially,
sure.
yeah. So essentially, it's kind of like in this case, the flow that hypothetical flow I was getting at here is to say like, if we have this user, we infer that he's not sleeping, he's anxious, we could potentially probe or consider that there's a correlation between these two. Then knowing that they're diagnosed with depression, at the moment, it's like depression is obviously relevant. It's always going to be relevant in this hypothetical user's life, but anxiety, not sleeping. Is there something right now we can do to alleviate this mood potentially? So then let's say it uses the cognitive behavioral therapy database, and it actually finds like, the one thing is like, oh, cool, there's breathing techniques, was the example. And once again, this is not medically diagnosed. We're just bullshitting here. It can then take all this stuff and then advise the user and say, hey, bro, how about we take a moment? We could try breathing techniques. Actually, one of the things we can do too here. I mean, what if this also stored this? Oh, sorry, guys. I'm excited. I'm just fucking hitting the keys over here. What if this machine or whatever it is, what if it actually advised the user to do breathing techniques in the past? What if it kept track of that? What if it had the success rate for this specific user? What if there was multiple techniques that it was keeping track of, saying, hey, this worked in the past. Should we try that? Here's what I'm going to do because I don't want to kill all your time, but this is super cool. It seems like you guys are actually enjoying this portion, which is dope. Here's just kind of like written out version here. So we know current mood, anxious, last 3 messages about sleep issues, active coping strategy being discussed, breathing exercises, tone preference, this chose to be gentle. Session start time is a little bit more for time logging. I don't remember if I had another use case in here. And then current topic, sleep hygiene is what it's called, right? Here, duration clears after 30 minutes of activity. So actually we can also use this not only for time logging, but to clear out the session. Storage, in memory, we're using Redis. It doesn't really matter. Long-term memory. We know that the patient's name is Alex. They came in with therapy goals originally. I want to reduce anxiety. I want to improve sleep. So here's a little black and white. Maybe the depression was just general anxiety disorder. Doesn't matter that it doesn't relate to, right? The other one, we're just making stuff up. Also, hey, they're taking medication. That could be relevant, especially with, different side effects. Trigger patterns, knowing what triggers the patient. Work deadline, social events, triggers the anxiety. Preferred therapist name. Oh, I don't know why I added that. That seems a little odd. Oh, no, it doesn't, because it's not real. Remember? It's just a chatbot. I guess humanize it. Emergency contact. And then this one encrypted, PPI, which is a little silly. All right, duration. This is going to persist indefinitely, right? It's long term. For this, we're going to utilize a Postgres SQL database, and it's encrypted when you're not utilizing it. Obviously at rest, maybe even in transit, doesn't matter for this. Vector memory, semantic search. Here we're going to utilize this database, which we talked about. Past therapy session transcripts. That could be important as well, right? And this kind of goes back to what we were talking about earlier that you all brought up. What are we storing long term? What are we storing short term? Yeah, maybe at that moment, right? Not everything appears so relevant to say, oh, let's store this variable, let's store that variable, but let's keep the records. And then if something appears to be relevant in the future, you could say, oh, go back. Oh, wait, did he ever talk about this? Was there another example where this thing triggered him in that way? Whatever it may be. We can now use all of the past conversations. Mental health resource library. Another thing, what is it? The DSIV, if I remember. It's a book on how to diagnose. The therapists use it. How to actually diagnose. We can put that in here as well. Different coping strategies. Crisis intervention protocols. That could be super important, huh? If now there's an emergency, it's just a chatbot. I don't think it's really trained. So maybe we can pass the buck to like a crisis hotline or something. Then duration, this should persist. You can update it weekly, especially these techniques may increase, right? They may update them. There may be new therapy sessions. There may be updated resources. Maybe these guys change their phone number. So this will you actually update it weekly. You can maybe have it, depending how you set it up with scripts or whatever, you can like pull it in. Okay, so this is where the data goes. That's just one section of it. What else you're gonna have to do today is map the flow. You only have to do one flow. If you wanna do a bunch of user flows, that's completely fine. But here's just a little example. The user says, I'm feeling anxious about the presentation tomorrow. Then here the bot can check session memory. It knows that we discussed, or the user discussed sleep issues just 5 minutes ago. And it knows that the user is anxious. This is just from session memory. Then it's going to check long-term memory, because remember, we're going through it's multi-layered. So then we're checking long-term memory. Okay, cool. We know who the user is. That's important if you're going to address them. I'm sorry, my dog barked. We know that there are known triggers anyway in the long term are work deadlines, right? Now we can kind of see that correlation here. We know that the past success, like I said, we can keep track of what's worked for this specific user. Box breathing, which is a specific method. Then we're going to go to the next layer, which is vector search. Now we can query anxiety, presentation, public speaking, and coping. Remember, it's semantic search. So whatever we're searching is not going to have this exact wording. And it doesn't need it. That's the whole point of semantic search. But this is our best, phrasing that our system came up with. So then what is it? It finds something. It finds technique, cognitive reframing. Then what? It found past sessions where Alex used grounding exercises. So then now you have to combine this. So it's like, okay, cool. We've taken what we got from session memory, long-term memory, vector memory. Here's the summary. This is the now what the like the RAG system is going to go off of or actually no, at this point it's not, the RAG's already done. This is what our LLM is going to go off of now to say, hey, this is all the information I need. It doesn't need anything else, right? That's how you clean it up. This is essentially we're cleaning data almost in a sense. So then now the LLM is going to take this and say, hey, Alex, I notice you're feeling anxious about work again. That also makes it a little personal, right? Again, which is true in this case, we saw the data. Last month, you found box breathing helpful. Would you like to try that? Or explore cognitive reframing for this presentation? This is one user flow. In theory, I could make 1,000 of these, 1,000,000 of these, but you wouldn't want to. Maybe make different paths if you'd like to. Step 3, implement the logic. You're not actually going to build this. Like I said, unless you really want to, go for it. Right? You have all the resources at hand, go for it. This is just mock code. We'll just talk about this a little bit so I can cut you guys loose. But here essentially, get therapy bot prompt. It's just one function. I think I only did one function, and this at the end. And then within this function, this is actually show full context, obviously start blank. Layer memory, we're starting with the session memory. How's it retrieving it? Now remember, this isn't real, it's just mocked. So session data, it's gonna get session memory utilizing the user ID. If the session data is found, it's essentially kind of going through it. What's the current mood, whatever. Like, so maybe here, this is just how we keep our session memory. Like, you know what I mean? This would be like our schema for session memory. Then here, we're going to go to long-term memory. And then same thing too. We're going to utilize the schema, pull up the information. 3, now we're going to vector. This is where, in theory, it's going to get a little more complicated. But essentially, relevant techniques. Search past success strategies right here. Remember, once again, I'll keep repeating this, it's all mocked. And then full context, past strategies, whatever. Privacy layer. Let's see here. This is safe confidential space. Data is encrypted. And then final prompt. Here we still have prompt engineering involved. You're a compassionate therapy bot helping. Here's the user's name. Here's the context that we gathered previously right now. Here's the user's current message. And then here's another prompt. Essentially respond with empathy using their known triggers and past success, blah, blah, blah. And then here it needs therapeutic guidance keywords. How do I help me? What should? Feeling, anxious, depressed, whatever. So this is just if we need a vector search. This is saying, like, right here we could already infer this is not going to be in our session, and this is not going to be in our long term, right? These are, now we're using these as triggers to say, hey, we're going to need actual resources for this. That's step 3. Step 4, this is the most important, but if you're using this, how we're discussing, you can already do this. It's just why. Why? Why are you using all 3 layers? Why are you putting certain things in certain things? And, why do you think that's not relevant to session? Why is that relevant to long-term? Exactly what you were discussing before. And here, this is just my version. I said privacy first is important. I talked about relevance. I talked about performance. And these are just conceptualized. And then I talked about cost optimization. That's essentially it. So today for the assignment itself, we go back to day 1 and we go to your assignment. It's literally the same thing. You choose an app idea. It could be, here are just examples. You can do whatever you guys want. Actually, before we jump into this, did anyone have questions about the lab, like what we talked about? Does everyone understand the relevance? Is anyone super lost? Cam?
How do you know what to transfer from short term to long term?
How do you know?
Do you just bring everything in?
No.
Right, you want to kind of filter it, right?
Yeah, because kind of like that's sort of like the thing here, like oh, did I click on the wrong thing? Yeah, I did. All right, 1 second. Let me move you guys. All right, let me go back. So here with the lab, the question is, how do you know? There's 2 ways to answer that, because the first portion is knowing. There is no, right? There's your best assumption. There's your best design. Let's say that. There's your best design on what you think needs to be done. How does it know, based on your design? That's another question. In my case, here within this code, it's not like the greatest, but essentially that's why I created this like schema here. So it's just like, oh, within long-term memory, this is like the schema. So it's essentially kind of saying like, in just theory, because it's just mock, it's kind of like if this information is updated, then that's kind of what we're now pushing to long-term memory. But
Okay.
remember, yeah, and then also as a fail-safe, with the vector search, in our example, we're actually saving all of the conversation. We're going to save the full conversations, the full transcripts, and at any point in the future, if we need to pull that up, we absolutely can. And then we can use semantic search to make our own patterns, add it to session, and then from there pass it to long term if needed. So yeah, you're correct to state this isn't explicitly stated in this. I didn't explicitly state that portion. For your concept, feel free to close those gaps. There's no wrong answer. Remember, it's just based on design, and then we can argue about design and find out who's right and wrong, but we really don't know until, unless we create something, in reality. And then Kathleen, you had a question?
Yeah, you kind of touched on it right there. So there's a difference between long-term search or long-term storage and something stored for the vector. Because like you mentioned in the workflow that it like the vector search found a previous conversation where a different technique was used. So then that was the vector. So that is vector memory. So that's that is a session not stored in long-term memory. It's a session stored in vector memory. Or is it the vector searching the long-term memory?
No, so the vector memory would be its own deal.
Okay, so it's its own database, it's a vector database. So you have to determine what's going to go in long-term memory. That would be kind of like a RDS, kind of maybe table structure or even graph, maybe. But like the vector memory is something, its own vector database. So you have to determine which one, like what session information goes to which.
Yes.
Or is it duplicative? Is it like could you have like all full sessions go into both long-term memory and vector memory for vector searching?
mm, I think the best way to answer that is to explain. I think the best way to answer that. So, okay. So for a moment, forget about vector memory. Let's just forget that even exists. We're not using it. Let's pretend. With session memory, you already know it's just current context. When we turn off the computer, it's gone. Long-term memory, you can think of it like here it says like facts, but it's facts relevant to the user.
Okay.
Preferences. So, for example, my name's Jonathan, right? Nice to meet you. That's going to go in long-term memory, just between these two. It's going in long-term memory.
Okay.
I'm
But you would
depressed.
never store a full session in long-term memory because that's just too much data.
Well, when you say session, and this may be a little confusing because of the example I gave, are you saying within like the
A chat
context of a
between
therapy session or within the
Yeah.
session memory?
Yeah, like like a use of the bot or like a use of, hey, I want to chat to the therapist today, right? Like one conversation. Would you store the whole conversation in long-term memory, or are you storing that in vector memory?
So,
A
in
chat
our
log. Yeah.
example, it would be in the vector memory. Now,
Okay.
if we didn't have, oh, you guys can't see me covering the screen. I went covered it with my hand. If we didn't have vector memory,
Mm-hmm.
it would be useful to say, hey, in long-term memory, we are going to just add a transcript that's now just saved in our thing. We can access it, give it its own
Mm-hmm.
chat log ID or whatever. You could,
Yeah.
but then even in that context, then the question is, what's the retrieval process? Well,
Yeah.
the retrieval process is the same as everything else. Same way you pull in a username, you're now going to pull in that whole conversation. There we go. We have this object now. Then with that object, then you can make the argument, cool, now I want to utilize it.
Mm-hmm.
Um, I mean, I guess in theory you could, because maybe if you, no, for our use case, I still don't think that's good. I think that's good for historical data.
Hmm.
But then the question becomes, if we want our chatbot to access aspects of specific chats, especially if we don't know which chats, that long-term
Hmm.
memory is not going to serve our purpose, because we're not saying, hey, give me this one object or give me this one variable. With a vector, oops, excuse me, with vector, it's literally taking whatever chunks of information, so in this case, that whole conversation, and it's
Yeah.
putting it in the database. And
Hmm.
it's instead of having it linear in our human readable sense, you can think of it. Um,
It's just
ev-
quicker. Yeah.
well, it's quicker, but the reason it's quicker is because everything's going to be broken up. Everything's broken down and it's placed together almost. This is a visual
Yeah.
representation of what's happening. It's
Hmm.
it's placed together based on how well it correlates with each other.
Yeah.
And that's why if that chat bot asks a question, oh, did we talk about sleep? Let's say, um, it can go into there, and maybe the guy never mentioned sleep in his life, but he mentioned staying awake, right? So
Or
then,
being tired. Yeah.
yeah, exactly. And then it can make those scores, those correlation
Okay.
scores to say, hey, we did talk about this. Here it is, and then it goes through that process. Where if it's in long-term memory, that's not how it's used. But you can make the argument that you would pull it from long-term memory, then have it go through the ingestion process to go into the vector database. But
Hmm.
that doesn't really make sense.
Yeah, that's not efficient. Okay, thanks.
Yeah, but that's a fantastic design question, design clarification question. And maybe for whatever use case you have, maybe it will make sense. So, what were we doing here? Today's assignment. Yeah, I mean, it's essentially what we did. Oh, no, sorry, that's the lab again. Give me one second, guys, right here. That's essentially today's assignment. It's to do everything we just did for your own app. But the one thing too, I'm sorry, where were we at here? Yeah, these are just examples of what you can pick. Pick anything you want. It absolutely doesn't matter. Everything else matters. You can map the data. So don't tell me like, oh, session memory is recent context. Actually create like a session memory schema and like give some like an example of like potential use case. And like today I just showed you one user journey essentially, right? It's technically one prompt in a session. You could do one or more, whatever you want. Each memory layer document specific data that belongs there. It's the schema that I told you about. Definitely, if it persists, for how long, who can access it? You can think of questions like that. What format is it stored in? This is a design, you want it as JSON, a database row. Do you want it in the vector? You guys tell me. Identify your primary driver. Ask yourself, which memory layer does 80% of the heavy lifting? So for like the therapy bot, long-term plus session. That seems like that's really going to be the majority. And then occasionally it's going to hit that vector for the resources. But if you do a legal analyzer, probably 90% is just going to be vector because it's going to go off of the law, right? Whatever predetermined law is in that thing. Calculator would only be a session storage. So think of how those layers work. And then also, it's not just what you need, what you don't need. Think of that, right? So if you're creating a calculator, it doesn't need vector memory. That's just the one example we'll talk about. You guys can read through the rest of this. Um, but yeah, that's essentially it. Just go through this, do your thing, and then at the end, we're going to talk about it. We're going to get one or more volunteer, and we can talk about your design, challenge it, whatever it is. Here would be my question based off of everyone's level of enthusiasm. Oh, actually, let me stop this. Hold on. Sorry, guys. Sometimes that stupid thing doesn't pop up to stop the recording and everything.